The first thing we need to establish with a question like this is to confirm that it is in fact a product. Okay, so it's one term multiplied by another term. That's a product. The approach to take then is to let u equal the first of the terms. So that's 3x squared plus 4x. And we're going to let v equal the second of the terms. The work that needs to be done then is to find the derivative of each of these. So the derivative of u with respect to x is going to be the derivative of this. The derivative of 3x squared is 6x, and the derivative of 4x is 4. Further to that, we're going to be finding the derivative of the v term, the second of our brackets. To do that, it's called v, so it's a dv, and it's with respect to x, so we're going to get the derivative of the bracket, the derivative of the 2x will be 2, and the derivative of the negative 1 is 0. So that we end up with 2 is that derivative. So we're now going to have 4 bits of important information. These 4 bits of information are going to go into the chain product rule, which is dy dx equals u dv dx plus v du dx. Remembering opposites, opposites. To then find the solution to the question, we use our rule, which says that dy dx is going to be u, which is 3x squared plus 4x. Having put the term for u in, we then go and multiply that by dv dx. So it's the opposite term. In that case, it's 2. And then we have the plus, and now we're going to form the second part of the product rule, which requires us to grab v, which in this case is 2x minus 1, and multiply that by the du dx, the fourth of these terms, the one we haven't used so far, and that's going to be bracketed 6x plus 4. Brackets are really important here so that we can keep and hold together all the algebra. Now, expansion here is less critical, okay, but in this case I'd probably follow it through. You're going to get 6x squared plus 8x plus 12x squared plus 8x minus 6x minus 4. That'll give us 18x squared. That's using that term and that term. And then we're going to have 8x and minus 6x. So that's plus 10x. And then we're left with a minus 4 on the end. That then is the derivative of the function that we started with right up the top here. And it's interesting, if you multiply, as an aside, the 3x squared by the 2x, you're going to get 6x cubed. And just out of interest, if you find the derivative of that, you'll get 18x squared, which just happens to appear as the lead term there. So we're on the right track. You could have expanded this function out and continued to do a whole pile of crab claw up in the original line there. But it's problematic for reasons we'll discover later on when we do some non-polynomial terms inside these two, inside the product rule. We have options here which involve crab clawing or foiling or distributing the brackets, expanding the brackets. That opportunity doesn't always exist. solve this question, we again recognise that it is a product of two terms. So we work on ourselves with the product rule, which is that the derivative of y with respect to x is u dv dx plus v du dx. Okay, so emphasising again, opposites, opposites. In this respect, we're going to let u equal the bracketed 2x plus 3, and we will also let v equal the bracketed 3x cubed plus 4. Defining the derivative of each is necessary to complete the rule, because the rule requires the derivative of v and the derivative of u. So we go ahead and find each. The derivative of u then, with respect to x, is going to be the number 2, and the derivative of v with respect to x is going to be 9x squared. That is to say, we bring the 3 down the front and we'll get 9, and we drop the power by 1 to get 2 up top. So the approach we take when we use the product rule is that we need these 4 values, or these 4 expressions, that allows us to put the solution together. So the derivative of y with respect to x is going to be u. In this case, that's 2x plus 3, times the derivative of v with respect to x, 9x squared. So again, diagonal pairs working across that way. We then have to add to this the derivative v in its bracketed form, 3x cubed plus 4, multiplied by the derivative of u with respect to x is 2. Again, opposites. So what we should find in our expression for dy dx is the 4 terms, the 2 original terms and the 2 derivatives. Because in this case here the bracketed terms are simply multiplied by a single term, and that bracketed term by a single term, it's probably warranted to expand these brackets out. That is to say, see if we can express this entire thing as a simplified polynomial. 2x times 9x squared is 18x cubed, and we'll have a plus 27x squared. Then at the tail of the expression, we're going to have 6x cubed plus 8. If we gather all that together, we're going to get 24x cubed, that is to say, using that one on that one, and a 27x squared plus 8. That's your final answer there. It's worth noting again, this final answer could have been achieved had we taken the original expression and crab clawed it out and got ourselves an extended polynomial, and then used the power rule to work out the derivative. Again, the problem with that approach is that whilst it gets us through on this particular question, we need the product rule for work we're going to be doing later on. Hence, we practice. Sound like a school teacher. Righty up. Thank you.